Hey guys, we are really close to being done now. We're actually in our last chapter. We did a Zoom meeting yesterday introducing conics, and we don't have that many sections in this chapter, and I think they're relatively short. So this video really shouldn't be that long. I did want to take a second just to let people know that for most of you, you've been getting the work in. That's awesome. So make sure you get our last homework assignment in. I'll probably post it on next week sometime. And for those of you that haven't been handing in work, your mark is dropping. I have sent out marks for that. I'm going to resend them out again today because I know some people didn't receive them. And please, for those of you that are handing work in, great, just keep doing that. Your marks, many of your marks are actually going up. Um, I guess the big thing is just try to make this last week and a half meaningful for yourself, and try to get something done. Try to get through things. And if you've been a student who has been doing things, which is the majority of you, just keep doing what you're doing because it's definitely been great. And I know this whole distance education thing it really sucks for everybody. I hate it in terms of my interaction with you guys, and I'm sure you guys aren't enjoying it that much. Getting away from school is always a good thing, but I saw two kids in Tim Hortons yesterday. They were social distancing, grade 10 students, and the boy recognized me and he said, he goes, "I really miss school," and I'm thinking like that's just not something you hear a teenager say very often. Yeah, I miss you guys, and I miss not being able to interact with you. So um, from my heart there. Anyway, so I'm going to jump into our topic of circles today. If you have not seen the Zoom video before this one, you really should. A lot of the formulas we talked about there are going to be used in this video. So please maybe stop this video and go back and watch that before you watch this one. Okay, so this was my first attempt at the lesson. For some reason, my computer froze, and it did not allow me to do any kind of editing. So I'm going to hopefully be able to, yeah, there we go. Okay, so there's, I'm just going to get rid of this dot here. So there's our circle there. So our circle is one of the four conic shapes we study. Comes from cutting a cone. If we think about a cone like that, and we have base to the cone. If you were just looking at the bottom of a cone, if you tilted it upside down, you would see a circle. But of course, if you were to cut a cone, this whole chapter about cutting cones here sounds cool. If you were to cut a cone, and then there's a few other words I should throw in it that I didn't talk about yesterday. There's a line right down the middle of the cone called the central axis. And if you were to cut the cone with a line that is perpendicular to the central axis, so if you were to draw a line across and that was perpendicular, and you looked at the bottom of that section, then you would actually see a circle because it would just be a smaller circle than the bottom of the cone currently has here. And so really that's sort of what the whole chapter on conics is about, just taking cones and chopping them into pieces. But there are obviously, it's not just some kind of like, wow, that was fun. There are applications to why we would do this, and I might get into a few of them, but I've tried to make things a little bit lighter for you guys. So we'll see where we get to with our time. Okay, so one of the things with a circle, we know circles are well, they're round, and to be round, there's sort of round, and there's like perfectly round. So I guess a circle would be perfectly round in that if you looked at the center of the circle, um, no matter which point you picked on the circumference, any point you pick, it should be the same distance from the center. So whether I take P1 or point P2 or any point for that matter, um, they should all be the same distance from the center. And that's actually the formal definition of a circle. It's called the locus, not locust, but locus, which means set of all points in a plane. So a plane means a two-dimensional surface that are equidistant from a fixed point. which we refer to as more commonly as the center. So that's actually the formal definition of a circle. So for example, if you had a point here, and you were to say that's your center, then the definition of a circle would be every point that you could draw that would be the same distance from the circle, or sorry, from the center, sorry. And I really botched this picture. So as I've mentioned in other videos, my artistic skills are horrible. But if you kept drawing points in, eventually what you would get is the outline of a circle. So all the points that I'm drawing in right now, they are the same distance from the center. So this must be a circle. That's the definition of a circle. Okay, so let's give the circle's center the coordinates h, comma k. You could use any letters you want, but I'm just going to stick with the letters they use in the book. And this is pretty common in most math books. They use for conics, they use the center as HK, but you could really use any letter. I know, like for parabolas, many teachers use like it's HK or PV sometimes. I use HV for the parabolas in grade 11. So, but whatever letters make you happy, but let's just go with HK for the center. And then the point on the circle, let's just pick one of the points. Let's give it the coordinates X, Y. So that is, we don't really know where it is, but it would have to have some kind of X, Y value. And then let's write a definition of how we could figure out where these points are on the picture. So the first thing is the center to that point, the radius, is the same distance no matter where I draw the point. So let's use R for the radius here. And what I could do is find the length of R. So let's find the length of R. And for that, I need the distance formula. Sorry, excuse me. So let's write the distance formula. Once again, please watch the video yesterday. So we said the distance formula would be the square root of x2 minus x1. So I'll just write it over here. D equaled the square root of x2 minus x1 and squared plus y2 minus y1 squared. And we square root all that. So I'm just going to shrink the screen here so we can see the picture still. So I'm going to say, let's go x. So the point at point P is x minus x1, which would be h squared, plus y. So the point at point P, y, minus the k value squared. And now if I square both sides, I get x minus h all squared plus y minus k all squared equals r squared. And in yesterday's video, I talked about this was the formula of a circle, but never really derived it for you. So this is where it comes from, just the Pythagorean formula, really. And we get this formula here. So let's take a, and oh, this is called the standard form equation, by the way. So let's say you had an equation that was written x minus 2 squared plus y plus 3 squared equals r squared. Okay, and for the standard form, we have to know that the center is h comma k, and the radius is r. That's the key parts you have to really understand to answer most of the questions in this section. And let's say you're being asked, like, where is the center? Where's the center for this thing? And maybe like, what is the radius? Or maybe a slightly trickier question, like what is the diameter of this picture here? So once again, feel free to pause the video. I'm going to change one small thing here because I just realized I goofed that. Let's say this was 25 here. So you were told like numbers here for h, k, and r's here. So you're told x minus 2 all squared plus y plus 3 all squared equals 25. So the center. Well, the center is where hk is. Now look at the standard form. It's very much like with parabolas. You got to be really careful how you interpret this. It's x minus h. And right now, it's x minus 2, which means the h value has to be 2. That's the only way you could plug a number into that and get an x minus 2 there. And the k value would actually have to be -3. And once again, notice that it's it's y minus k, and here we have y plus 3. So we would have had to put a -3 into the brackets to get that to appear. So the center would be at 2, comma, -3 on the graph. Another thing to pay attention to is, you might remember with transformations, we talked about left, right, up, and down translations. This would actually, minus sign here, would move the circle right 2, and then a plus sign is going to sound really weird. The plus sign with the y would move it down 3. And so that's quite maybe a bit more confusing to think about translations. So I just remember h and k values. Now the radius has to do something with the 25, but notice that it's r squared equals 25. So r squared would equal 25. So the radius would have to be the square root of 25, which is 5. And then the diameter of any circle is always double the radius, so 2 times the radius. So the diameter would have to be 10 units here. Okay, so let's do a question. It's kind of a reverse question. So let's say you have a circle has a center at -1, comma 8, and you're told and a diameter equal to let's say I don't know, 13. This is kind of an ugly number here. And the question is, write the equation for the circle. Okay. So once again, after all these little examples, I would encourage you to pause the video. I think I'm going to stop saying that because I'm sure you're getting tired of hearing it. But I would encourage you to pause it and see what you can do on your own here. Okay, so the standard form is x minus h all squared multiplied by y minus k all squared equals r squared. And what are we told in the question? Well, we're told the center is -1, 8, which means the h value is -1, and the k value is 8. So I already know 2 letters here. And in fact, in most of the questions in this whole chapter, you're just finding these letters, like you're plugging them back into the equation. So it's actually a fairly easy chapter compared to like trigonometry and logs and stuff. Those are really hard chapters. And then what do we know about something else? We know the diameter equals 13, but I know the radius would be half of the diameter. You have to divide the diameter by 2, so it'd be 13 over 2. And I would stay away from putting decimal numbers into your formulas because it just makes it so much harder to work with decimals. Just stay with fractions, way easier with fractions. So here we have x minus h, so h is -1, so x plus 1, so it actually went left 1, sounds weird, plus y minus k, so -8, so it actually went up 8. And then I have to do r squared. So I know r is 13 over 2. So r squared would be 13 over 2 all squared. And what do you think? Well, 2 squared is 4. And what's 13 squared? 13 squared with 13 squared. 169. There we go. So 169. I'm sure there's a joke in there somewhere. But let's say 169 over 4. Okay. So we have x plus 1 all squared plus y minus 8 all squared equals 169 over 4. And so that would be writing the equation from information that's given to you. Okay, so let's try a question maybe that's not one we've sort of seen already, and let's look at what we call general form. Okay. Now, general form is probably a little bit of, you just remember some stuff from grade 11, but it is completely review. But once again, it might be a while since you've done it. So I can see why this might look a little bit tricky here. But let's say the question was given to you as x squared plus y squared minus 14x plus 6y minus 6 equals 0. Okay, now this actually is the equation of a circle, but it might be hard to see why that's the equation for a circle. You can see you've got 2 squared terms, x squared and y squared, and you have a plus sign between them. But what's really important with circles is the coefficients have to be the same in front of the x and y squared terms. So this is definitely a circle, but the question might be something like, where's the center of this circle, or what is the radius of this circle, or what is the diameter of this circle? So clearly, the way it's written right now is what causes the difficulty in answering those kinds of questions. So let's find the center. Let's find the radius, and let's find the diameter. And so really to do those, those three questions, you're going to have to know H value, V value, and the R value. You have to know those three things there. And in order to make this work, we're going to have to go back to grade 11 and remember how we did this with parabolas when it was written in this kind of way. And that was using a technique called completing the square. So you got to kind of know about factoring and how to write perfect square trinomials. And that's sort of why in grade 8, 9, 10, 11, we just beat you guys down with factoring. It's so important to be good at factoring at this stage. So what we're going to do here is we're going to rearrange our terms. So we're going to have x squared. I'm going to bring the other x term close to it. I'm going to leave a little space here. I'm going to try to make a trinomial here. And then I move the y term over and group it with the other y term. And then plus a number. And then I move the constant number over. That means the number without any variables over to this side. And what I'm going to do now is get rid of all this because that's kind of causing me some problems. And I'm going to write this. I'm going to write plus space and space. That's just how I do it. So what I'm going to do is I'm going to group my x terms and y terms together, move the constant number over, that is the number without any variables, and I'm going to add numbers now to both sides, but whatever I add to the left, I have to add to the right to balance it up. So what I'm going to try to do is complete the square on this. I need to make this a trinomial. That's a perfect square trinomial. And just to remind you what I mean by that is I'm just going to go over here. If you have something like a plus b all squared, that equals a squared plus 2ab plus b squared, and also a minus b all squared equals a squared minus 2ab plus b squared. So those were something you would have been taught in grade 10 and 11, and we also covered them earlier in the course, perfect square trinomials. So when we do this, what we have to do, the process of completing the square, is you take, let's go right outside of my formula here. I take the b value, here for the quadrilinear term, I divide it by 2 and I square it. So negative 14 divided by 2 is 7, and squared is 49. And now I have to add 49 over here, which is why I have the space over there. And then I complete the square for this part. And so now I have to look at the 6. I divide it by 2, which is 3, and I square it, and I get 9. Okay, and I get 9 over here. So now I complete the square. I go, let's complete the square here. So we're going to go that thing all squared, which would be x minus 7 plus y plus 3 equals 6 plus 49 plus 9. So 49 plus 9 is 58, and 58 plus 6 is 64, I think. Yeah, that seems right to me. Okay, so good or bad? Good or bad? Good or bad? Pretty good, right? Because now we've gone from general form, which is this monster, to standard form. Okay, so what's my h value? Well, that would have to be 7. What's my k value? That has to be negative 3. And my r squared value is 64, which means my r value is 8. So where's the center? Well, the center is h comma k. So 7 comma negative 3. My radius is equal to 8. And my diameter is 16. Okay. So I'm going to give you one more question, same question in general form, and I'm going to make numbers up here, so I'm hoping it's going to work out nicely, but I think as long as I choose some even numbers, we should be pretty happy. So x squared plus y squared equals, or no, equals, minus 8x plus 6y, excuse me, Got a nasty cough. Minus, let's do 2 equals 0. So pause the video, see what you think. You guys do that, and I will solve it now. Okay, so let's bring things over. So let's go x squared minus 8x plus some number plus y squared plus 6y plus some number, need to create trinomials here, equals, bring the 2 over, and I'm going to add the same numbers to the right-hand side. So complete the square on the x part. Negative 8 divided by 2 is 4, and I square that bad boy, and I got 16, which means I add 16 to both sides. Same with the y's. 6 divided by 2 is 3. That's the same question as above. 9. Niners. Maybe I'll color that differently just so you can maybe see where they came from. So like that blue, make that blue. Okay, so basically whatever I add to the left, I have to add to the right. That's just sort of basic arithmetic. So let's do some complete the square then. So x minus, well, what goes in here? Well, it's got to be half of 8, which is 4. Also has to be the square root of 16, which is also 4. Plus y plus, well, it's the same as above, but half of 6 is 3, and the square root of 9 is 3. So it's going to be a 3 in there. And now I've got 2 plus 16, or maybe let's go 16 plus 9. 16 plus 9 is 25, plus 2 is 27. Eeks! Not a perfect square. So what's the h value? H value is 4. The y value is negative 3, or the k value. Oopsie, sloppy there. K value is negative 3. And the r squared value is 27. Okay, so the center, that's very easy. Hopefully by now. Center's got to be hk, which is 4 comma negative 3. And the r value, though, r value would be the square root of 27, so it doesn't work out nicely for us here. And in grade 12, we do not write that as a decimal. That would just be like something a grade 9 would do, right? So we don't touch the calculator, right? But we do know that 9 goes into 27. 9 times 3 is 27. So this would reduce down to 3 root 3, right? So working with radicals. Radical. Okay, so what is the center? Center is 4 comma negative 3. What is the radius? Well, the radius would be 3 root 3, right? And what's the diameter? Well, the diameter is double that, right? So 2 times 3 root 3 would equal 6 root 3, or you could say 3 root 3 plus 3 root 3, that's the same thing, which is 6 root 3. Okay, so I'm going to stop the video there. Really quick look at circles. I might put a little bit more on that today. I'm just going to look over the questions here, but I think that's a good start for you guys, and I hope you are doing well.